Hello, this video is for the lesson that's presented in Chapter 1, Lesson 3 of the textbook from the class website. And it is titled Order of Operations, and the objective is that you'll use order of operations to evaluate expressions. We know what evaluating is all about. Let's actually solve it and come up with a value, right? So here we have this massive flag. And before I go on, let's look at the vocabulary, kind of jumping ahead of myself. Only one vocabulary term here, and that is order of operations. So the example here, the little story they give us kind of, is this big giant flag. That's a pretty big flag. I mean, you can tell in relationship to the size of the houses and the intersection. That's one giant flag, and it's made out of flowers. So it's a flower flag. There are about 2,000 plants in each of the 50 stars. So each one of these stars here have about 2,000 plants that make up the white stars. There are about 64,100 plants in each of the 7 short stripes. So we see the short stripes across here. There's 7 of those. And 106,700 plants in each of the 6 long stripes. So we have 6 long stripes, the 7 short ones. And then the blue region surrounding all the white stars there contains about 198,900 plants. You can approximate the total number of plants by evaluating the following expression. 50 times 2,000, 7 times 64,100, 6 times 106,700, and then add on another 198,900. How we built this was, how they built that was, you'll notice that where the numbers come from, 2,000 plants and 50 stars. So we get the 50 times 200. The 7 short stripes here that have 64,100 plants each. The 6 long stripes that have, right here we get those 2 numbers, the 6 long stripes that have 106,700 plants in it. And then the blue region there that is the 198,900. To evaluate expressions involving more than one operation, mathematicians have agreed on a set of rules that are known as the order of operations. So the definition for order of operations is, we could say that it is the set of rules that are agreed on by mathematicians. And the operations that's in there, we see addition, we see 3 plus signs in there, but we also see some multiplication signs in there. So we would have to agree upon, do we do 50 times 2,000 and add 7 and multiply that times 64,700, then add 6 and then multiply that. Well, I wonder how that would work out, but I know that's not the way we want to do it. There's a different way of doing it. The rules are a little bit different that the mathematicians have agreed upon. So this is the order of operations here. First, we have to evaluate expressions inside of grouping symbols. We'll talk about what those are in a moment. Next, you have to evaluate all powers, or that is to say numbers that have exponents. We've talked about exponents and powers in the past. Also, you would then, after that, the next step would be to multiply and divide, going from left to right, and then finally add and subtract, going from left to right. This little graphic here kind of gives us an idea of what each one is in the order that we need to do it. The P represents parentheses, so we first do anything inside of parentheses or any other grouping symbols. It could be brackets, and we'll also talk about how fractions plays a part in this whole grouping and parentheses concept later. Next, we have to deal with anything that has exponents. The E is for exponents. These are the step 2 powers right there. So powers have an exponent in it. So any place we see an exponent, we have to do that after we do any grouping symbols. Then multiplication and division, going from left to right. Many people believe that you have to do all the multiplying first and then the division. No, they are equally as important. We work them going from left to right in the whenever we in the equation, just like we read a book going from left to right. We also do our math problems going from left to right as well. And then finally, after we've done the parentheses and all the exponents and done all the multiplication and division, finally we can do all the addition and subtraction, and that too is going from left to right also. A memory device for this is please excuse my dear Aunt Sally. So PEMDAS is an acronym for the phrase please excuse my dear Aunt Sally. What it is Sally did, I have no idea, because I know they've been saying that since I was a kid, and I believe my mother said that they've been saying it since she was a kid, and Mom's like in her 70s now, so I guess they've been saying it, I'm sure, for at least 60-something years, right? 60, 70 years at least. Whatever it is she did, I do not know, but we should excuse her. So please excuse my dear Aunt Sally is a memory device for this. So let's go ahead and also noteworthy here, keeping a notebook is not a requirement for this class, keeping notes and so forth. However, it is a good idea to be successful. It's not something I'm going to grade. I'm not going to insist that you keep notes and write this stuff down. However, it is a good study skill to have. So you should include material that appears on a notebook like the one shown in your own notebook. So they have this notebook. See the binding here. What they're saying is that if you see something like this, that you might want to go ahead and write it down in your notebook for future reference. And also cell phones, taking pictures with your cell phone. Learned that a few years back. I was doing a presentation in class, and one of my students said, "Hey, Mr. T, could you back up one slide?" And so I'm like, okay. I backed up thinking they were going to write something down in their notebook, and they jumped up, took a picture of the screen, and like, okay, got it. So that's another strategy that you might use as well. All right, so let's move on. We're going to see how can we use the order of operations on the flag situation. So using order of operations in example 1 to approximate the total number of plants in the flag described above, use the order of operations to evaluate the expression. So we talked about where these numbers came from earlier. So we had the 50 times 2,000 here, and we had the 7 times 64,100, the 6 times 106,700, and then finally adding on the flowers that are blue there surrounding all the stars, which is 198,900. Well, first we have to multiply, right? Please excuse my, well, there's no parentheses, there's no exponents, so we need to do the multiplication going from left to right. So the first one we come is 50 times 2,000 is 100,000. 7 times 64,100 is 480,700. 6 times 106,700 is 640,200. And then finally we bring down the 198,900. Now we can go through and add all of these. So whenever we take these 4 values here and take the sum of those 4 values, remember sum means to add, or the total of all 4 of those, we end up with a total of 1,387,800 flowers. So there are approximately 1,387,800 plants in the flower flag. Probably took a long time to plant those. So let's talk about grouping symbols. So we haven't, in this problem here, we had no grouping symbols, we had no parentheses, and we had no exponents. So let's talk about examples that use grouping. So grouping symbols such as parentheses and brackets and fraction bars are common grouping symbols. Many times we don't think of fraction bars as a grouping symbol, but we do know, or we should know, that we have to first simplify the numerator and simplify the denominator before we can do anything else, before we can do the division, because all fractions are division problems. So before we can do that division, we have to simplify the numerator and the denominator. Then we can do the division. So that's why they're talking about here that fraction bars are also a grouping symbol. Grouping symbols indicate operations that should be performed first. So that's why we have to take care of the numerator and the denominator first, or any other groupings symbols that we see, such as in examples A and C here. We'll look at that in a moment. So for example, compare the expressions 3 times 2 plus 5 and 3 times the quantity of 2 plus 5. Notice that the parentheses, I read them as the quantity of. So if I were saying out loud in class 3 times the quantity of 2 plus 5, you know 3. Oh, he said times the quantity of, so it goes in parentheses, and then he said 2 plus 5. So if I were to read this aloud, that would be 3 times the quantity of 2 plus 5. So to evaluate 3 times 2 plus 5, you would multiply first, so that's 3 times 2 is 6, and then add the 5, so 6 plus 5 would be 11. So this first example here would come out to be 11. But let's see what happens whenever if we use the parentheses here. So let's evaluate the 2 plus 5 first, and then multiply times 3. Well, 2 plus 5 is 7, and 7 times 3 is 21. So the first example here has a value of 6, whereas the second one here, same number, same operations, just a different order of doing them. This second one produces a result of 21. So it does make a difference. So watch out when grouping symbols appear inside other grouping symbols, as in part C of example 2. Work from the innermost grouping symbols out. So it's talking about C down here. Notice that's parentheses inside of brackets. We would have to work from the inside, working our way outside. Look at that in a moment. So evaluate the expression. So using grouping symbols. So we're going to take, we need to do the 17 minus 2.3 first. And that would be 14.7. Now we can multiply it times the 8 and get a product of 117.6. We could also call this 6 as 6/10, and we read this as 117 and 6/10. That's why many people would call this 117, or they might read another number like this one, 198,900, right? And the reason that I don't do that is we say the word and. The only time you use the word and is whenever you see the decimal here. So I would read this 117 and 6/10, because the 6 is in the tens place. So if you have a tendency to use the word and elsewhere, let's see if you can try to break that habit. I know it's a tough one to break. Be quite honest, until as a math teacher, I was guilty of it myself. So on the second one, remember fractions are grouping symbols also. Fraction bar is a grouping symbol. And so we have to take the numerator, 14 plus 6 here, and we also have to take the denominator, 12 minus 7 here, and kind of think of it as grouping. We have to first do the addition here and the subtraction here. Then we can go ahead and divide and finally get a result of 4. And then finally on part C down here, notice that we have brackets parentheses inside of brackets. So we had to do the parentheses first. So we end up getting the 13 plus 9 is 22. Now we see we have the bracket part is now 36 minus 22. We brought that 5 over here. And now we do the 36 minus 22 is 14. So the difference of 36 and 22 is 14. And then we can take these factors of 5 and 14, multiply those together to get a product of 70. The product is the result of multiplying factors together. All right, so checkpoint. Let's go ahead and do a couple of these. First, notice that there's no exponents in any of these. They haven't really gotten to exponents yet. And I don't think we do. Let me take a peek. Yeah, we do in the next examples. Okay, so good deal. I want to make sure we get some exponents in there. So on this one here, we don't want to take 63 and subtract it from 28 first. We first have to do the division here, right? And then subtract that from 28. So 63 divided by 7, well, I know my 9s pretty well, and I know that 7 times 9 is 63, so 63 divided by 7 is 9. And then 28 minus 9 is going to give me 19, right? So the answer for number 1 would be 19. Let's look at some grouping ones here. We have to consider the numerator and the denominator as grouping. So we first have to do the 70 minus 9.2, and we'd have to get the result of that, the difference there, and then we could divide it by the 3 plus 5. Now let's see how this works out. 70 minus 9.2. Well, I know 70 minus 9 is 61. And then I want to take another 0.2 away. So that's going to be 60.8. Now I could check my mental math and do 8 times 8 plus 2 is 10. Carry the 1, and 0. Am I correct here? I just got lost. I need to add these two together. Yeah, 8 plus 2 is 10. Yep, carry the 1. 1 plus 9 is 10. Carry the 1. And 6 plus 1 is 7. So I would get to 70. I'd have 70.0. So, yep, I'm good to go there. Now I need to divide that by 8. And this one's not going to work out very friendly on that. Yeah, let's go ahead and do it. Why not? So this is going to be 60. A little bit of review on using the division algorithm, right? That's where you put what's being divided inside of this like little half box thing, and then throw the 8 out there. Our decimal is going to be up here. We line it up, and we say how many times will 8 go into 60? Well, I know that happens to be 7, and 7 times 8 is 56. It might not be too bad. Yes, we're going to be all right. And then 60 minus 56, remember we subtract this, 60 minus 56 is going to be 4. Bring down the 8, and 8 will go into 48 6 times. 6 times 8 is indeed 48, and we get the 0, so we got the 0, and that means we're finished. So our answer is 7.6 equals 7.6. Had to use a long algorithm there. And then on this one here, let's do the parentheses first. So we got our brackets here, and we had to work from the inside out. So 11 minus 7 is going to be, what is that, 4, right? And then we bring down this times 2. We still have 72 divided by whatever all this comes out to be, right? And so we have 72 divided by, and then 4 times 2 is 8. And I know that 72 divided by 8 is 9, because I know 9 times 8 is 72. All right, so there's 3 of them there on the checkpoint. One using order operations there, and where we know we had to do the multiplication or division first, then we could do the addition and subtraction. The other one is using a fraction and recognizing that the numerator and the denominator is a concept of grouping, and or parentheses if you want to look at it that way. And then number 6, where we had parentheses inside of a bracket. All right. On our, I believe example 3 is going to be our final one. No, we got example 4 also. So looking at this here, evaluate the expression when x equals 2 and y equals 5. Well, we know that evaluating means that we're going to substitute these values in where we see the x and y over here. And get my highlighter where we see this x and y here. We're going to substitute that 2 and that 5 in there. So we do that. Do what's in parentheses first. 2 plus 5 is 7. 4 times 7 is 28. Then x equals 2, y equals 5. So we're going to go ahead and substitute in the 2 and the 5 for the x and the y. We do the inside the parentheses first. And so please excuse my dear Aunt Sally, parentheses first. So 2 plus 5 is 7. Now we need to do exponents. So we have an exponent here. 7 squared is 49. We brought down that 3. Now we can do the multiplication. 3 times 49 is 147. On this one here, let's see. This one right here, number 9 seems like it wouldn't be too much. So we're going to do 3, and we're substituting in when x is 4, y is 2. So 3 times 4, and then we're going to subtract that from 2 times what is y? 2. We substitute that in. We got to do the multiplication on each side of the subtraction first. So 3 times 4 is 12, and 2 times 2 is 4, and 12 minus 4 is 8. So number 9 has a value of 8. And then finally over here, 0.05, and then in brackets, we're going to have y. Y is 2, and we're going to subtract from what's in parentheses. X in this case is 4 minus 2, and then our bracket. So we have to do 0.5, our brackets, 2 minus, and then 4 minus 2, in this case is 2. And we'll have our bracket there. And then we have to do 0.5, and we're going to multiply that times 2 minus 2, which is 0, and anything times 0 is 0. So in this case, number 10 is going to equal 0. All right, we have a real world situation here, sewing. You buy a pattern and enough material to make 2 pillows. The pattern costs $5, so you got to pay $5 for the pattern. Each pillow requires $3.95 worth of fabric. Notice how I use the word "and" for the decimal, so $3.95 worth of fabric, and a button that costs 75 cents. Find the total cost. Well, first we need to read and understand. So we are buying a pattern plus fabric and buttons for 2 pillows. So let's go ahead and we know we have to find what the total cost is. So we're going to make a plan, come up with a verbal model for that. We know that the total cost is going to be whatever we have to pay for the pattern, plus however many pillows we make, multiplied by the cost of each pillow. So the cost of each pillow, if we put that into an expression, then we end up with the cost of each pillow is, well, the cost of the fabric, $3.95, plus the cost of each button. We're going to multiply that value, or that total, by 2, because that's the number of pillows that we're making. But we also have to add 5. That is the cost of the pattern that we got in the first place. So taking the sum of 3.95 and 0.75, we get 4.70, $4.70. Now we're going to multiply that by 2. We have to do the multiplication before we can do the addition. And that comes to a product of 9.4, $9.40. Now we need to add the $5. We come to $14.40 total cost for the 2 pillows. Now, we could use estimation and look back. This look back here is telling you, hey, does your answer make sense? And it's always important to ask yourself, does my answer make sense? If I would have got a total of if I would have messed up on a decimal place, $144, well, that doesn't sound right. Or if I got 50, if I messed up someplace here in the multiplication, it's like $63.29. Well, that I might want to check my work. So we could use estimation. We look back on it, realize that $3.95 plus 75 cents is pretty close to, this is almost $4. This is almost $1. So that's just about $5, right? And so we get the $5 here. It's almost 4 plus almost 1 is pretty much 5, estimated 5. And then we have 2 pillows, so we're going to take 2 times 5 and get 10. Add the $5 to the pattern, that'd be $15. So using estimation, we can say, does this answer seem like it makes sense? Is it pretty close to correct? Does it seem like it'd be okay? And indeed it does. So many times we can use the strategy of estimation to estimate whether or not, or to reason whether or not our answer makes sense. And finding out and checking if your answer makes sense is a very good strategy to use. So here in our guided practice section, vocabulary check, give 3 examples of grouping symbols. Well, we had parentheses, and so it could be done with parentheses. We could also have brackets, and we could also have a fraction bar where we have to do the numerator and the denominator have to be simplified before we can do the division. Describe in order the steps you would take to evaluate the expression 12 times the quantity of x minus 3 squared, where x equals 5. Well, first we'd have to plug 5 in, right? So we'd have to plug 5 in first, and then we would have to do the parentheses first, do 5 minus 3, because we can't square it till we know it's in the parentheses, and so 5 minus 3 would be 2. Then we have to square the 2 and get 4, right? And so we got a 4 from all that, but we still need to multiply it times this 12, and that would give us, what, 48, right? So first, substitute the 5, do what's inside the parentheses, then the exponent, then the multiplication. Please excuse my dear Aunt Sally. And for these here, let me see, good example on this one here. If we did 15 minus 3, let's talk about how they'd be different. If we did 15 minus 3, we would get 12. And 12 times 4 is 48. But we have to do the multiplication first, right? So 3 times 4 is 12, and 15 minus 12 equals 3. So big difference, 48 and 3, 2 different values. So you've got to make sure you follow the order operations. On this one first, on this one here, notice that the division comes first. So even if you didn't know the order operations, you'd work from left to right, and you'd get lucky and get this one here. Correct. 48 divided by 6 is 8. And then 8 plus the 2 is 10. And then another one, oh, check this one out here, number 7. The exponent's actually inside the parentheses. So we have to treat the parentheses like its own little problem. It would be like 3 squared minus 2, right? We have to figure that out first. So before we can subtract the 2, we have to know what the 3 squared is. And so that would be 9 minus 2, and then we get 7. So what's in the parentheses is 7, and then 17 minus that 7 is going to give us 10. The answer for 4 and 7 turn out to be the same. All right, so that's everything I have for Chapter 1, Lesson 3, Order of Operations, where we learn to use the order of operations to evaluate expressions.